today with division will be simple, especially to start out. If you have two numbers under square roots that are being divided, you can just divide them if they divide unevenly. The problem will lie when they don't divide unevenly, like 7/5, then we will have to rationalize. Now we know how to rationalize square roots, and especially those of you doubling up, you're doing it a lot in geometry right now. But we're also going to look at how to rationalize cube roots and fourth roots. So that'll be the new piece to our rationalizing today. So just like we did with multiplying yesterday, again, the index has to be the same in order for you to be able to divide or rationalize. So they show that when you're dividing them, you can actually keep them in separate square roots or cube roots, or you can put them in under one big cube root. What that means is when it's all under one big, some of you would then see that you could reduce, for example, 2/4 to be 1/2 or something. But most of these are actually just going to be evenly divisible. So numbers 14 through 18 just say divide and simplify. We are assuming all variables are positive, so no absolute value bars needed. So 243 divided by 27, and we'll get 9. So since these are both under square roots, we can divide and keep the number under square root, and the square root of 9 is 3. And technically positive or negative, but we're just going to assume that they're all positive because we don't see a negative in front of them. Okay. The next one, we have the cube root of negative 81 divided by the cube root of 3. So we can divide those and get the cube root of negative 27. What is the cube root of negative 27? Garrett? Negative 3. Now let's throw in some ones with variables and numbers. So we can still divide the numbers. 12 divided by 3 is 4. We'll keep it under a root. Now what do I do with the exponents here to divide x to the 4th divided by x? Austin? Subtract them. So we have a little imaginary 1 there. So 4 minus 1 will get me x cubed. And then we just simplify like we did yesterday. So the square root of 4 is 2. X cubed is not divisible by the index of 2. So we break this down into the square root of x squared and the square root of x. And the square root of x squared would be x. So we're left with x under a radical. So we'd have 2x root x. Okay, we get into some cube and fourth roots. So as long as they are both the same index, you can just go ahead and divide them and use your exponent rules. So we should divide 192 by 3, and we'll get 64. Again, follow your exponent rules. 8 minus 1 is 7. And then we actually know what the cube root of 64 is. Now 7 is not divisible by 3, so I work my way down. X to the 6th would be. So I'll break this into x to the 6th and x to the 1st. And then the cube root of 64 is just 4. No, it's just positive 4. And here we'll divide these to get x squared. And then that will stay under my cube root. So 4x squared times the cube root of x. Now our fourth roots, a lot of you may not know your perfect fourths, so you may want to jot them down somewhere. So we know our perfect squares and our perfect cubes. Perfect fourths would be what? 1 times 1 times 1 times 1 is 1. How about 2 to the 4th? 2 to the 4th. Sam? 16. 3 to the 4th? Garrett? 81. 4 to the 4th? Sam? 256. And I'm not going to write down any more, but you could obviously figure them out if you wanted to. Most of our numbers don't get really that large, so if they are divisible, it's usually by one of these first 3 that we see. So anytime you're reducing a fourth root, these are the numbers that you would need to think of as in terms of breaking them down. Now these are all fourth roots here, so we can just divide them. 1024 divided by 4 will get me the fourth root of 256. And then we will subtract our exponents, 15 minus 1, x to the 14th. And then we can break this up to the 4th root of 256. Again, 14 is not divisible by 4, so work your way down. 13 is not divisible by 4, but 12 would be. So I would make this the 4th root of x to the 12 times the 4th root of, and then we just subtract. 14 minus 12, I'd still be left with an x squared under my radical. So this will be 4. This will be x cubed. So we'll have 4x cubed times the 4th root of x squared. Okay, so a lot of these problems really are just one extra step dividing, and then you're doing what we did yesterday, simplifying. Now, the remainder of the problems we'll see today are not going to divide it evenly, and you'll notice that the directions tell us that we have to rationalize the denominator. So the first one on the front, we're just reviewing square roots, which we all should know how to do. So for this one, we would break it up into the square root of 7 over the square root of 5, and then we would rationalize the denominator. Now, when we rationalize, we always just say just multiply by whatever's in the bottom. That's what we've said. But really what we're doing is we're making the denominator be a perfect square, which then takes the root away. Now what you're going to see on the back is we may have a cube root or a 4th root. So you can't just multiply by it once to get a perfect cube. You might have to multiply by it twice to get a perfect cube, or 3 times to get a perfect 4th. And we'll see that on the back. Now for square roots, we just have to multiply by it once. And I would like you to put in your notes what this gets you. We'll get the square root of 35. Normally we don't write this part. The square root of 25, we just write 5. But in these problems, I would make sure that you're getting a perfect whatever, cube, 4th, in the denominator before you take it. That'll be 5. Square root of 35 is not reducible any further, so that would be our final answer. Okay, we'll look at a couple more square roots, and then we will add in some variables and cube roots and 4th roots. So always check and see if they're divisible. 3 divided by 5 doesn't go in evenly. So then we would go to rationalizing. Now this is a square root, so we just need to multiply by it once. Now in the numerator this time we can multiply those to get the square root of 15. The denominator we will multiply to get the square root of 25, which again is 5. Can I reduce this further? No. One number is inside of radical, one number is outside. We cannot divide them. We also can't reduce it. Our next two are square roots as well, but they have variables and exponents. Now you have 2 options. You can actually reduce this fraction. If you were to put them all back under one big square root, you could reduce 2/10 to be 1/5. And you could reduce x cubed divided by x to be x squared. So if you want to simplify first and then rationalize later, that's an option. Or you can just go straight to rationalizing and simplify at the end. It does not matter. What would we prefer, do you think? Do you want to simplify first or just rationalize first? Here, one simplifies, so that's what I'm going to do. So again, 2/10 would become 1/5. X cubed divided by x would be x squared. That's positive, so that goes in the numerator. And we'd be left with a y in the denominator. So then I would split this up again. And you could leave them split. You don't really have to put them together if you just want to divide them mentally. Then we would rationalize. We actually could have just taken that square root there, but I already wrote it out, so just put it together. Now, in the denominator, we are going to get the square root of 25y squared, which will just come back down to be 5y. We know that the radicand, when it's a square root, will always come out to be itself. And then before you circle your answer, always double check that nothing can be reduced inside this radical, which it can. You can take the square root of x squared, which is just x. So we should have x root 5y all over 5y. And we don't have any other terms that can be divisible by the outside numbers, and the inside can't be reduced. So that would be my final answer. Now in the next one I'm going to show you if you were to just go straight to rationalizing, which you can simplify this first if you wanted to. Subtract these and make it x cubed. But I'll show the opposite method of just going straight to rationalizing, which is a method you can choose as well. Does not matter. You're going to simplify at some point, it's just whether you want to do it to begin with or at the end of the problem. So this one I'll go straight to rationalizing. We'll get 3x to the 7th y. In the denominator, we're going to get 9x to the 4th y squared, which comes back down to be 3x squared y. What can I simplify further? Sam? X to the 7th. So I can break that into x to the 6th and x to the 1st. And again, I'm doing that because my index is 2, and I need to divide by my index to get what I have. So I'm going to do 6 divided by 2, which is x cubed. Everything else will stay the same, and inside I'll have 3. I still have that x to the 1st, y, all over 3x squared y. Still not done. So if you choose not to simplify at the beginning, just remember to always make sure you're simplifying completely at the end. The last thing we can simplify here are the outside x's. We have x cubed and x squared. We subtract those. 3 minus 2 is 1, which will get me just x to the 1st, all over 3y. All right, now our next couple are cube roots. Okay, so put a little star next to these. When we rationalize the denominator for this one, we're not going to do what we normally do. And you could reduce this if you wanted. The 4/6 could become 2/3 if you would like, but I'm just going to leave it because most of you won't think to do that. Some of you will. You're welcome to do it, but normally we just multiply by the cube root of 6x to rationalize. But if you notice, if I were to multiply these right now, I'm going to get the cube root of 36. Is 36 a perfect cube? No. So when rationalizing, you actually have to multiply by either a different number here to get it to be a perfect cube, or what I suggest doing is multiplying by another one. That way I have 1, 2, 3 of the same things, and so whenever I multiply the cube roots, I'm going to get a perfect cube. 6 times 6 times 6 will get me 216, which is a perfect cube. Okay, so jot down in your notes, multiply denominator by the denominator twice. Now if it were a 4th root, you'd have to multiply by it 3 times so that you'd have 4 of them because it's an index of 4. Now some of you will just know that you need to multiply by 36x squared and you won't write it out twice. That's perfectly fine too if you just want to think logically through instead of writing it out. But this kind of makes sense logically of how we normally rationalize and how we're going to add that piece to it. So then we just multiply straight across the top and straight across the bottom. So in the numerator, don't forget your index of 3. We will get 144x squared. Now the denominator, let's just check it to make sure that we're not crazy. This will be the cube root of 216x cubed, which then does get me back to be just 6x, which was my radicand. Now up top, I need to break down 144. Do not put 12. That's the square root of 144. If we're doing the cube root, we have to think of our perfect cubes. So I think 8 will be divisible into that. 8 and what? 18. Now, x squared is not going to be able to divide that, so we'll just keep that the cube root of x squared. Take your perfect cube, the cube root of 8 is 2. So now I have 2 times the cube root of 18x squared all over 6x. So close, but not complete until we have nothing left that can be simplified. The two outside numbers, 2/6, as a fraction, are both divisible by 2. So this would become 1/3, or just the cube root of 18x squared over 3x. But if you'd like to put the 1 there, you most certainly can. See if you guys can try 24. Again, make sure when you rationalize the denominator that you do get a perfect cube in the bottom of your fraction. Which I saw a lot of you getting that. So nice job. All right. Last problem then is a formula question. And you'll see one like this on your homework. Basically, they just want you to rearrange the formula to solve for a different variable. So right now, this is an acceleration formula, a equals. They want you to solve this acceleration formula for t. So you're going to have a final answer that says t equals a whole bunch of stuff. All you're going to do is use inverse operations to move stuff around. And then we will have to rationalize our denominator at the end because of the directions. So I have a equals d divided by t squared. Now you want to solve for t. So normally you want to leave t where it's at, but the problem is it's in the denominator. And we don't want like what does 1 over t equal, we want to know what t equals. So the first thing we would do is we would undo division with multiplication. So we would actually multiply by t squared on both sides. So we'll have a times t squared equals d. Again, our goal is to get the t by itself. So what do you think I would do next? Good. Good. Divide by a. Make sure your d's and your a's don't get confused. And then all we'll have to do is square root. So I have t equals, and I'm going to split up that square root to make it the square root of d over the square root of a. And then they do want us to rationalize our denominator. So we'll just multiply by the square root of a. You only have to do it once because it's a square root. And so we'll get t equals the square root of dA all over a. Sometimes they'll then ask you to plug a number in for something or give you numbers to evaluate. I don't think your homework does yet, but sometimes they will ask you to then find out what time would be if distance were this and acceleration were this. You'll plug them in. See if you guys can complete the closure, taking this distance formula for the distance an object will fall and solve it for t with a rationalized denominator. Again, the answers are provided. It's not a super long assignment, so it's a lot shorter than last night.